Alright, in this video we reach a mechanical milestone. All of the chains, the drive chains are attached, and I'll show you how I did all of that, how to tighten the chains, how to connect the ends of the chains, as well as there's a problem with the Z-axis that I also fixed in this video. So follow along and I'll show you how I did all of these steps. So I attached the rods coming out of the X-axis motor, and you come all the way here and stick out of both sides, on this side and that side. And this is made of 1/4 inch music wire, and it turns out that 1/4 inch music wire is a little bit bigger than 1/4 inch. And I found that out because my bearing would not fit over the rod, and I had to put it on the grinder and just take a little bit of metal off. That's why it's a little shiny on the end there. But the bearings on both sides now fit, and this will allow the sprocket to go on the outside there. And the other thing that I did is I put in the collar on the Z-axis down here, and I didn't have enough room to put a collar in underneath the coupler on the Z-axis motor. So what I ended up doing was taking a little bit of wood off this motor mount so that the motor could sit a little bit lower, and so the entire room inside that motor mount is now occupied by the coupler. Alright, there's a problem here with the Z-axis that I need to fix. Right now the Z-axis is very rigid, both up and down. I mean, it moves a bit, that's just the wood flexing. But the reason it can't be pushed down is because of this collar, and the collar is right now is rubbing directly on the wood, which is increasing the friction. And the reason it's directly on the wood is because that 1/2 inch bearing is a very small 1/2 inch bearing, so it leaves a lot of room for the collar to rub up against the wood. But a more severe problem is because up here I have the bearing on the top. I really need the bearing to be on the bottom of this piece of wood so that I can put another collar on this side, and that would stop the flexing from going up. Right now, the only reason this router bracket cannot move up is because it's directly connected to the coupling, which is directly connected to the motor shaft. So right now, any upward pressure on the router is being directly transferred to the stepper motor. And I want that to instead be transferred to a collar that would be riding up against a bearing. So yeah, I need to fix this. Alright, so I've taken everything apart, and I used the lead screw with the original bearing on the underside here to mark out where this bearing needs to go. And the reason I have to do that is because I no longer have an accurate center hole. So drilling this out so that this bearing can sit flush in there is going to be a bit difficult. I'll need to clamp the work surface down to the drill press very securely to prevent the drill bit from wandering, because it no longer has a center reference to keep it steady, and it's going to want to jump all around the board. So I'm going to do this. I'll drill this out on this board, and this is the top, and I'll have to drill out the bottom as well. For the bottom, that's here. For the bottom, I will be having a similar issue. Even though I've already got a little bit extra drilled out here, I'll just be drilling this out more. So, alright, I'm going to take these over to the drill press and get those holes drilled out for the bearings. Alright, so this is what I'm looking for. I've got this is the, let's see, the bottom piece, and it's clamped down, and I line it up as good as I can to inside the pencil mark that I drew around the bearing, and then I make a very small cut, check the alignment, and adjust as necessary until I get the cut falling entirely within the circle that I drew around the bearing. And once it's all aligned, I'll go ahead and make the cut. Alright, now that the two collars are in place, one down below and one up above, and there's no motor mounted at all, even without that, the router assembly cannot go anywhere. It can't go up and it can't go down, and we have the ability to turn the threaded shaft and raise and lower the router mount assembly. So yeah, now I just got to put everything back together, but the nice thing is that the router mount assembly is now secure even without the motor. I used the Dremel tool with this cutoff wheel to make two little flat spots on the rod sticking out, so that the sprocket will have a little bit better of a grip with the set screws. The two sprockets are mounted on each side of the gantry now. They're mounted down low, so they'll be in line with the bearings and the rails. And I'll need to come over here at the end and build some type of piece of wood sticking out here to attach the chain to on either end. Here is the board that I measured and cut for both the front and the back. There's one in the back just like it. I'm going to raise it up off the floor here, off the table, by about 2 of those 6mm plywood, so about 12 millimeters. And I've got the hole cut here for the chain to come through, and just testing the alignment to make sure that when the chain is on the sprocket that it will line up with that hole, which it seems to be fairly well in alignment. It's a little hard to tell right now with one hand because I can't stretch the chain tight, but with two hands it looks like it is aligned just where I want it. So now I need to attach the board. Right now it's just kind of loose here. I need to attach the board to the front and back of the CNC machine, and then I should be able to stretch the chain tight. Alright, so I cut the chain to length, and right now I've secured both ends to the boards with some clamps, and the chain runs from the fixed end here around the idler sprocket up to the sprocket on the motor shaft, down to another idler sprocket, and then over to another fixed end. So what happens is, as the motor turns, then the gantry will, let me just push the gantry, and you can see the motor will turn, and the gantry is moving along, walking along the chains. So I don't actually have a chain breaker for this size of chain. I probably need to get one. So in the meantime, I just used the Dremel tool to grind off one of the pins flat, and then knocked it out with this homemade screw here that I just ground down the tip to be able to knock the pin out with this hammer. Just set my vise here on the table and put the chain in there, and then with this screw was able to knock the pin out to be able to get the chain to the correct length. So alright, so that is the X-axis chain, and the next chain to go in here is going to be the Y-axis chain. I need to mark the holes on the side of the gantry where that y-axis chain will exit, and then I can fix both ends of that chain to the gantry. Alright, all of the chains are now attached. There's the one on the side that goes all the way up to the armature of the x-axis. It makes kind of a giant upside down V. And we also have the chain here on the x-axis, or sorry, the y-axis. This is the y-axis, and it just kind of wraps around this motor. Let me give you some details. So I followed the method that Build Your CNC uses to tighten the chains by putting the eye bolt and wrapping the chain through the eye bolt, and then using a hose clamp to tighten it. Then we can use the nut on the end of the eye bolt to tighten the chain. And I'm using some nuts with nylon inserts so that they don't come loose, because there's nothing really to fully tighten these nuts up against. I mean, you know, you don't want to crank it down too hard. You want the chain to be tight, but you know, not overly tight. So there needs to be something on the nuts to be able to hold them in place. So that's why I'm using the nylon locking nuts. So the way this works is, as the motor turns, then this sprocket will turn, and as the sprocket turns, then it effectively walks along the chain. So, you know, we're used to like a bicycle chain where the chain is in a loop and the point of rotation is fixed, and as you turn the chain around the point of rotation, then the chain moves. But what we're doing here is the chain's not in a loop, it has two fixed ends, and as the point of rotation moves, then that's what moves. The chain remains in place, and the point of rotation kind of walks itself along the chain. So for the let's see, for the y-axis, the chain is wrapped around like this. It comes through here, around the motor, and around the idle sprocket, and it's a very similar process. It just walks along that chain. Now I need to still cut off some of this chain. I need to just get a chain breaker for this so I can easily take these excess pieces of chain off. Now, one thing to note also is that when tightening this chain, on this chain, I can tighten it from either end. And the first time I put one of the x-axis chains on, also I could just tighten the whole thing. But when it comes to the other side, when I went to tighten that one, I have to tighten these separately. This one and the one over here have to be tightened separately. And that's so that the chain tension will match this. So in other words, if I tried to tighten just one side, then I would end up trying to twist this armature. So once you get one chain tightened up, then the other one has to be tightened up on either side independently. Alright, so that is it as far as the mechanical connections, other than the limit switches. So I need to put the limit switches in and then get all the wiring done. But that'll be enough for this video. It's effectively a fully mechanically complete CNC at this point. Alright, bye.